Hi guys, and welcome to the next video. In the previous video we spoke a little bit about the backups. If you don't know what I'm talking about, check it out. And today I wanted to finish the last topic from the frames, which is the user frames, because that's the one left and it's very important, guys. You will do it straight away after you get to the new robots, and you're going to use them to move also, because I don't know if you remember in the jogging video I told you about the user frame, that there is a user frame that you can move around, so it's useful. You gotta teach it and you gotta use it in your programs so you know where the robot is. So let's get to it. Okay, so the user frame, guys. What is it? I'm going to use an example. So imagine that you're going into a bar and your friends are waiting at the table. So what do you know? You know that your friends are at that table. Probably they send you a text message or something saying, hey, we're sitting next to the window, like the third or fourth table or so on. So what's that for you? That's your user frame. That's how, when you get to the bar, you know where to go. And it's the same with the robot. The robot needs to know where it's working at. You have your word frame, which is your base frame, which is where you are at, where the robot is at. And that's the word frame. So that's user frame 0. But you want to use user frames to navigate through the points and to just know where the robot is at. And at the exercises I will explain you why, and you can do cool things with it. So also why you are using it. So when you are at the bar and you will go to the bar itself or to the restroom, you will always go back to the same point and you know where your 0 is. So it's the same for the robot. You want to refer all of your movements to one point. So it's easier for you to track the robot program. It's easier for you to understand what the robot is doing. So what is the frame? So basically you're going to tell the robot, like you're going to define a 3D plane for him, and you're going to measure the distance from the robot to that plane, and that's how the robot will know where he's working at. But before you do it, you need to have pretty accurate TCP, because you're going to use that TCP to teach the frame. If you don't know how to teach the TCP, check out my video with the TCP. Okay, so like in my video, I'm going to use a finger as my tool frame. So imagine that's my TCP, and I taught it's pretty accurate. And right now what you're going to do, you're going to take that finger and point it onto 3 points that are going to define the plane. Because there are 3 ways how you can teach your tool frame. Number 1 is the 3-point method, and that's the most common used. I would say that's the one that everybody is using. There is a 4-point method. And why do you have the 4-point method? So it's connecting the 3-point method. So you're going to make your frame, and with the 4th point you are moving it to some point. So when it's useful, so imagine you have a pretty big table, for example, or a table with a lot of fixtures on it, with a lot of obstacles that won't allow you to actually teach the tool frame as you want. But let's say that that's on an angle, right? But it has like 4 legs or 1 leg, and underneath you have the parallel I don't know, table or a floor that is mounted to. So you know that they are on the same angle. So what you're going to do is you're going to teach the tool frame here, and then with that 1 point left, the 4-point method, you're going to shift it from here to here. So you don't actually need to go to those points. You're going to only to tell the robot, hey, the plane looks like this, but it's not located here, it's located here. And that's why you use the 4-point method. Cool? Pretty cool. You will see it better when I do it in the RoboGuide. And the last one is, of course, the direct entry. And that's the one when you get the measurements from, for example, a measuring team. They measure the frame, or you get it from the CAD data from the model that you've got from your designers. So you can type it in, and there you go. There you have your user frame. But what is it for? So you're going to basically tell the robots that, hey, the 0 is not in here, it's somewhere here. So like in the bar. You get into the bar, but your 0, your reference point, is the table with your friends. And you're going to refer all of the movements from that table to somewhere. So you will say, well, it takes me 3 steps to get to the bar, and it takes me 25 steps to get to the restroom. That's how you know, because you count the steps. So the same for the robot. If you're going to tell him that that's his 0, now he's going to calculate everything from this point, not from the robot base, not from the user frame 0, but the user frame that you taught. And that's why you teach the frames. So it's easier for you to understand the program. So that's it from the theory, guys. Let's get to the exercises. Hi guys, so let's get to the exercises with the user frame. As I told you, what is the user frame is, you can think of it like a 3D plane actually, that's somewhere in the air. So I think it's going to be a little bit easier for me to describe it in here on the picture. So I will show you what's going on. So first of all, let's select the user coordinate system or word, and there you go. So we have the user coordinate system selected right now. Let's make sure that the user is 0. And right now the user coordinate system is going to show us, there you go, the position calculated, as you can see, from the robot base. So in here, as you can see, we have the Z and the X distance from the robot base. Actually not the base, but as you can see, it's like I've told you on the other video, it's right here, like in the middle of a crossing of the axis 2 and axis 1. So what's going on right now? So right now, as you can see, that's our word coordinate system, because user 0, so user frame 0 is the same as the word coordinate system. So we're using the right hand rule where the finger is pointing forward, that's X plus, then to the left Y plus, and up the thumb Z plus. So what's the deal right now? So what we want to do is we want to move that coordinate system, that one that you have in here, to the edge of the table right here. So we want to navigate through that table and we want to calculate our positions from there, because you want to know that when you are at the edge of that table, you are in the point 0, 0, 0, and you want to make a straight line of 200 millimeters. So you know that you're going to move that way. How we're going to do it? We need to define, guys, the user frame. So let's do it. So we're going to go to menu. We're going to go to setup and frames. And right now you want to go to the user frame. You need to make sure that the user frame is selected. So you're going to click other and click the user frame. Now you're sure that you are in the user frame menu. Now you need to select the user frame that you actually want to teach. So we're going to use the second one. As you can see, it's 0, 0, 0. So let's go inside. And as you can see, the coordinates of that frame are 0, 0, 0, which means that that user frame is exactly the same where the word frame, and it's located right here. And I'm going to show it to you. So let's select the user frame number 2. And as you can see, it's still user frame number 2. And the coordinates did not change. The position in the user frame is the same as the word frame. See, that's the word coordinates. Those are the user coordinates. So what we're going to do, we're going to teach it. So it will shift from here to that point. So I have a program ready for it. So I'm going to be using that. First, let's go back to our frames menu. And we're going to do all 3 methods. Let's start with the first one, with the 3-point method. And like I told you at the beginning, what we need to do, we need to define the origin point, the X point, the X direction, and the Y direction, and that will shift our frame from here to wherever we want. In our case, it's going to be that point right here at the table. So first of all, guys, like always, please remember to put the comment in. So you want to hit enter, and you want to put a comment in. I'm going to use the keyboard, and I'm going to name it table. There you go. Guys, name your frames, because you're going to get lost later on, especially if you have more than one frame, and it's really helpful. It's just helpful to do it. Okay, so what is the orient origin point? So the orient origin point, you can think of it as a reference. That's where you're going to start where like the zero of your coordinate system is. That means you're going to select and say, hey, this is the zero of my coordinate system. I'm going to measure everything from this point. So that means if I'm going to choose that point, that means wherever I go from that point, the robot will tell me, hey, you moved 200 millimeters from that point. You moved 100 millimeters from that point. You moved whatever millimeters from that point in the X, Y, Z direction and the rotation. So that's the orient origin point. So basically you need to think it as a 0, 0, 0 point and as a base point, as a reference. And from that point, you're going to show the robot which way to move into the X direction and which way to move into the Y direction. So let's move to that point. Like I said, guys, I have a program ready for it, so it will be just faster. So let's move there. Okay, and now the other very important thing, like I said in the introduction to that video, guys, remember that you gotta use your tool that you taught to show where your frame is. So as you can see, I'm using my pointer. I'm using my tool number 10 because that's the one that I taught for the pointer. If you don't know what I'm talking about, check out my video from the teaching the TCP. And as you can see, with that TCP, I'm getting to the edge of that table, the very edge of that table. So with that TCP, let me just change it to 1, for example. And as you can see, the TCP is shifted to the other point. Or let me change it to 2. Well, which is actually, it looks like it's the same. But you need to make sure that you are using the correct TCP, because the TCP, the end of the tool, is showing the position for the frame. That's your reference. It's like pointing the finger, like you would take your finger and touch with that finger to this point and saying, this is the place where I will start. So that's why, guys, you need to use the correct TCP. Otherwise, if you're going to use wrong TCP, your frame will not work. So you gotta use your correct TCP to show the correct point. So like we're using user tool number 10 because that's our pointer that we taught in the previous video. And with that tool, I'm showing the robot what's what. I forgot to mention that at the beginning of the video. So select your tool to make sure you're using the correct tool to show the robot the frames. Okay, so we're at the first point. As you can see, the angle, does it matter? No, it doesn't matter. You can come at this angle, at that angle, doesn't matter. The only important thing is the actual TCP, the end of the tool, to be at the point. So let's touch it up. So what I'm going to do right now, let's go back to our frames. We are at the orient origin point. That's our 0. That's where I want to do my reference from. And you guys gotta hold shift and hit the record. Bam. Point recorded. As you've seen in here, it says recorded. Awesome. Let's go to our second point. Again, I'm going to move it with the robot. Bam. We are at our first point, which is the X direction. So what I'm saying right now, guys, is that whenever I am at that table, when I move from here to there in the Y direction, that means I'm going to move to the I'm going to move X plus towards here. So whenever I'm going to be at that point, I'm just going to hit X plus. The robot will just move straight here, right? So that's our X direction. You're asking me if there is any minimal distance. Basically, guys, I think minimal is 250 millimeters. That's the minimum that you need to actually teach the frame. But basically, the farther you can get, the better. So the farther you can move from the orient origin to the end of your frame, the better. It's going to be just more accurate. Okay, the same story. We hit shift. We're hitting the record. Bam, point recorded. We got the X direction defined. The last one, Y direction. So we know that that's X, so we want to make that one Y, right? So let's move over there. There you go, we're at the last point, and guys, the same story. We're going to hit Shift and record. Point recorded, new position calculated, all of the points are used, and that's your frame. And now, guys, let's take a look what happened. So right now, when we're going to select, I hope it will work in here, our frame. Yep, we have it. And now we're going to go to position. And let's go to our origin point. Let's go to our first point. There we go. We are right here, right now. And now we go to the position, and guys, 0, 0, 0, which means you are using the user frame, frame 2, tool 10. That means that this point from now on, that's your 0, 0, 0 point. That's where where all of your points will be saved as, according to that point. Because let's change the word frame. Bang, that's the word frame. So from this point, we are 300 millimeters in X plus, we are 200 millimeters in the Y negative, and we are 155 millimeters down in the Y from the robot base. But in the user frame, we are at 0, 0, 0, which means if I'm going to move now in that user frame, let's make sure again we have the second one, yep. In the Y positive, just the X positive, just the X is changing, as you can see. Got it? Now we're going to move into Y positive, because we thought the Y positive this way, we're going to move the Y. Bang. See how that's changing? So we're changing now according to the 0 that we thought. So the robot is saying, that's showing us the distance from this dot to that dot. That's what you're seeing right now. That's this position. So when you're going to touch up a point right now, it's going to show you that distance. Okay, there is one more method. That's called 4-point method. And there is a system origin in here. So what does it mean? Like I said, now we know that I want to move around the table, but I can tell where I want to shift my 0. Because I want it to be in here. I want it to be the 0 on the edge of our pointer that we used for teaching the TCP. So let's do it. Let's move here to that point, and that's going to allow us to shift that dot right here, like that frame from here to here. So I have that point taught. Let's move to it. I'm sorry, I do not have that point taught. I thought that I did it. Okay, so let's move it. So I'm going to do it with you guys. It will take a little bit more time, but let's do it. So let's go there. Let's jog the robot to the point. We're pretty close. So as guys you can see, I'm using the right hand rule to get to the point, because I know that my X that I thought is this way. It's the same as a word frame actually. So my X is this way, my Y is this way, Y plus, and Z plus is up. And again, the right hand rule, guys, remember about the right hand rule. It applies to the user frame that we taught. So you always know what buttons to push in order to get to the correct point, right? So let's align those pointers. We're almost there, a little bit more. Pretty close though. So guys, we're doing this together. Takes some time. As you can see, not too many buttons. Oakley dokley, I think we got it. Pretty nice, huh? There you go. Very nice. Let's go a little bit higher. Up. Perfect. So we add the dots. And what's going to happen now, guys? Now our 0, 0, 0, take a look at that. Position, our user frame. Look, so we are 122 millimeters from here in X, 123 in Y, and 75 millimeters in Z, right? So you need to calculate like this, this, and up. Right now, we're going to go to the frames. I'm going to touch up the system origin, and I'm going to show you the position again. Record. The values changed, and now when we go to the position, bang, 0, 0, 0. Now all of your movements are going to start from here, and you're going to start calculating everything from here. So the frame that we taught, X plus, Y plus, and Z plus up, did not change. We just actually grab it from here and drag it to this point. Because look, right now, I'm going to hit our X plus, nothing is going to change. The robot will move forward. Look, X plus, forward. A little bit slower. Y plus will go left. Y minus will go right. Z plus will go up. So nothing changed, guys. The only thing we did is we moved from here to this point, and now all of the points are calculated from here. Now, if that would have been on a 45 degree, then that's a different story. Because that's what we are using the user frame for, actually, to change, to be able to jog the robot according to our fixture. So let's try rotating it. If I'm not mistaken, we should rotate around Z. Yep, there you go. And what we can actually do right now is to teach a new frame. So let me remove our okay, guys. So I moved the table as you see, like I've said before, and we're going to make the frame for this table. So how I'm going to do it is I'm going to define my orient origin, which is going to be in here. I'm going to tell the X positive direction to be in here, and my Y positive direction to be in here. So it's going to be different than the word frame. So I can show you why we're actually using the user frame. So let's do it. So how we're going to do, let's move to our orient origin point in our 3-point method. So that's the second point for me. There we go, here we are. Let's go to the frame setup. Let's choose a different frame. Let's choose frame 3 again. Name it, guys. Always remember, name it. So I'm going to do the table 45. Okay. We're going to use 3-point method. So what I'm going to do is I'm going to record the orient origin in here. So we got it. Now let's do the X plus in here. So that point is going to tell us the X plus direction. So let's move to that point. Okay, we are at that point. So let's teach it. Okay, we got it. And the last thing is the Y. So that's my third point in my program. Let's move there. There you go. And let's touch it up. Okay, we get all of the points used. As you can see, we have our new position calculated. And as you can see, it's off by 45 degrees from 180, which is from here. It's rotated minus 45 degrees, which is correct. And now let's go to our orient origin, which was that point. And when you hit the position data, when we select the correct user frame, which is user number 3, bam, 0, 0, 0. So that's where we're starting our calculations from. Now when you go back to Word, so this point, you can again see how it's calculated. So we have 473 in the x plus, minus 23 in the y, which is pretty close, and minus 154, 55 actually, from the z, so going down. And as you can see right now, that's how we are located. So we rotated 45 degrees. As you can see right now, that's how the frame is located also. You have the X, I'm sorry, that's not ours. And now, guys, take a look what's going to happen. So you want to move, because right now, let's choose the world coordinate system as we have it. And guys, let's move in the, let's move in X plus. You know how the robot is going to move, right? The robot is going to move in here. When you select the Y, it's going to move in here, right? So let's take a look. X plus, there you go, according to the right hand rule. The Y plus, according to right hand rule. Let's take it back to our second point. Okay. Now, guys, let's select our user. Remember to have the correct user selected. User number 3, that's the one that we taught. And take a look what's going to happen when I hit the X plus now. Remember, that was our X plus, that was Y plus, right? Take a look. I'm going to move in X plus. We're moving right like the table is, like we taught our user. Look again. Y minus, we'll go, I'm sorry, X minus, we're going to go right there. Right across the line, right? Now what about Y? Y plus, you see? That's going to be our Y plus. Let's click it. Oops, I'm sorry, that's Z. Y plus. Right on the edge of the table. That's what we wanted. That's how we wanted to move. We wanted to move according to the frame that we taught. So it's easier for us to operate on that table, because guys, if you want to move according to that edge using any other frame, even the tool frame, it's not going to be possible, because that's your tool frame. How are you going to move like straight according to that line? Well, you can, right? We can go like Z plus, then we can go Y minus. Okay, we got here. Let's get here. So we're going to do Z plus, Y minus, and so on until we get to the edge. Can we use our world coordinate system for it? Yeah, of course we can. But again, it's going to be the same story. Now we're going to do X minus, Y minus, X minus, Y minus, and we're more or less in the edge. But why we need to do it? If we can just select the user frame, select the user frame. Again, make sure that's number 3. And guys, I wanted to move according to the line. I taught my X in here. That means when I go X minus, I'm going to go just straight around the table. There you go. Perfectly straight, like the line was, like we taught our user frame. That's the beauty of the user frame, guys, because you want to be able to navigate according to that table, not according to the word frame, because it's just for you, it doesn't make sense. For you, it's easier to drop and pick stuff from that table if you move according to that table, like how it's located. Again, that's your frame, X plus, Y minus, correct? Now, why do we have the 4-point method? I'm sorry, the direct entry. Because, like you see, the Z plus right now is located the other way. And I wanted to face up. I wanted to kind of match to the word frame. So what I could have done, I could have chosen the orient order in a different point. So the Z will point in a different direction, but I didn't do it. Or I was not able to do it because I'm not able to get in here, for example. So what I'm going to do, I'm going to rotate it according to what I need. So as you can see in here, I have an x-axis and I need to rotate it like 180 degrees around, so it's going to point up. So let's do that. So let's go to our frame that we taught. That's a little bit more advanced. You don't need to know that now and fully understand. I can explain that better later. But let's go to direct entry. As you can see, all points that we taught stayed exactly the same. And what you want to do is you want to rotate around that x. That's the x. So you want to rotate around that, like up. So we have 179. We're going to put 0. I should put like 0 points. Let's do that. 0, 2, 4 to be exact. Bam. See what happened? We rotated our Z plus here. Of course, the Y changed. It has to change. We have no other option. We can rotate around the Y instead of the X, and then the Y rotation, the Y direction will stay. The X direction will change. But I didn't care about that too much. I wanted to have the Z plus up. So right now, guys, take a look. The X didn't change. We go X plus. We're going around that edge of the table. We go X minus. We go back. Now the direction of Y changed. So as you can see, we need to go Y minus right now. We go around the table. But what I wanted my Z plus to be up. And that's what I have. Awesome, guys. That's why you use your user. That's what the user frame is for. So to make your life easier, guys, is to navigate around whatever fixture you're working on, so you can navigate according to how it is located. That's the first thing. And second thing is to know what are the points. So let me show you one more thing. Let's go. Because guys, now we have our tool frame taught, we have our user frame taught. So we know that we're going to like basically move that dot around our working area. So take a look at that. Let's go to our user. I'm going to go back to the origin point. So we are actually at the 0, 0, 0 position. And now take a look at that. Let me add a few points. I'm going to touch up the point. We're going to do that later. I'm going to teach you all of that later on. I just wanted to show you something. And our position is 0, 0, 0, right? And now, you know, for example, you want to draw something, right? Let's say you want to draw something. So let's say you want to draw an L, right? L shape. So you want to draw it like from here to here and then here, right? And let's make that, I don't know, 200 millimeters. And the lower dash, we can make 100. So what you're going to do, you can make a point right now, because you know exactly where you're at. We can put in here 200 millimeters. We can make one more point. And on that point, we can put in here 100. Guys, look, I didn't move the robot, right? But because I know how my frame looks like, look what's going to happen. Let me just move that point. So we're actually going to draw an L. So I'm going to move that. See, like many functions. I'm telling you guys. Oops, not this one. I'm telling you guys. There is much more to learn. So trust me, there are going to be more movies. If you want, of course, don't forget to like and subscribe, so I know you like the work, and you can find out much more about the FANUC stuff. Okay, so let's go to our beginning of our L that I created just from the points, guys. Again, just from the points. I didn't move the robot, but because I know the frame, I know the movement, guys. There you go. That's our first point, right? Now look where the robot will move. So we're drawing L, guys. Look, L, 200 millimeters and 100, so probably somewhere around here. Just let me make sure that I put the correct sign. Of course, I did not. That has to be negative. There you go. That's because we thought X plus, we rotated, so X plus is here. I'm sorry, Y plus is here, and we want to move there. Okay, let's move to our next point. Bang. We moved there. And we're going to move here. Bang. And what did we do? We just did the L shape, right? I should have changed the movement type to linear, but guys, too much information for you. I just create a program doing the L shape without moving the robot. Why? Because I know my frame, guys. That's why the frame is so important, so you can figure out where the robot is at. You just hit the position button and you know that we are 100 millimeters negative from Y. Oh, okay, this is my 0. That's why we're using the user frame. Okay guys, I hope you enjoyed the video. Don't forget to like, subscribe, leave your comments below, and see you in the next video. Bye bye.